Hello everyone and welcome back to another Universe Sandbox 2 video, and today we're going to be tidally locking another one of the planets to the sun. So if you remember last episode, we did Jupiter here. Got some pretty interesting results of that, as I was thinking maybe it'd get a little warmer, but yeah, unfortunately we didn't really get Jupiter that high on the temperature tidally locking it, even though it's not too far out. It's just too far away to get any proper warmth from the sun, even though it's tidally locked. And yeah, we've done all of the outer objects now, apart from Saturn, because there's really no point. We've done Uranus and Neptune, they practically did nothing. We've done Jupiter, and it still doesn't really get much heat, so there's not really much point in Saturn. We've done all of the inner planets, apart from Mercury now. So this will probably be the final part of this series, as it's the last one we need to do. So yeah, the grand finale, I guess, will be Mercury. So we're going to see how hot it gets, because as we know, it's already hot. It's a lot hotter than some of the other planets even got to already. So we're going to see how high we can get Mercury to go. Because if you remember, when we did Earth and Venus, we got very, very high results. And Mercury is even closer to the sun. So will it get even crazier results? That is what we're going to be finding out today. But before we begin, guys, just a massive thank you as always for coming back to all the videos, leaving likes, subscribing, all that stuff. It means the world. It's absolutely amazing. But yeah, with that all out of the way, guys, let's get into this. So we're going to head to motion down here. We're going to click Tidally Lock. So we're going to watch this go down. We're also going to set up the good old options up here, so let's go ahead and do that. We want to do that one actually. There we go. So let's get all of our good old settings up here. I'll get rid of those ones, I don't need them. So there we go. All of the ones we need, all the interesting ones. So there we go. Now all we need to do, is head to motion. Click Tidally Lock like that. So now it is tidally locked to the sun. So this face will always be facing the sun. This side will not be facing the sun anymore. So we're going to see how hot this guy gets. Because right now we can see the hottest point in the daytime is about 247 degrees. The colder points go down to the lower 100 areas. And some of it goes down to almost 60 and 70 in the very darker areas up in the north and south. But now we're going to click play. And we're going to watch this unfold. So we're going to start to see that the white area, that's probably going to expand out or get a lot hotter. As we can see here from the temperature gauge, you can see the white number on the very right hand side of the gauge. That is going to slowly increase, and the dark side will probably get colder, but we'll have to wait and see on how that works. So yeah, we can see it's starting to get cold already. We can see the hot side is really heating up, very, very high, but obviously being this close to the sun, we're going to get a lot of warmth, because obviously with the sun being that big in the sky, that's a lot of sun rays we're getting here. So yeah, and there we go. And if you remember as well, if we look at Mercury's stats in general, it only takes about 83 to 85 days to go around the sun. I'm not sure if this one may be slightly altered, but it's still relatively in the correct area there. So yeah, very, very close orbit to the sun. We can see here very, very low numbers, like if we orbital period, if we go to this one for instance, 0.3 AU away, we're not far from the sun whatsoever, so that temperature is probably going to skyrocket once we get going here. So as we can see, right now we're in the 300 area, so we're going to see how that works. So how are we doing here? Rightio, let's see. So how we are, right? And Mercury's albedo as well. It does absorb quite a lot of light as well, as we see here. We go down to no, composition, sorry. So where are we? So yeah, composition. Where are we? Oh, I've lost it. I can't remember where it's been. It's been a while since I've looked for it. It's in a surface. It's in surface, yeah. So down here, 0.12 in the albedo there. So yeah, it does absorb quite a decent amount of light there. So let's go ahead and really get this going now. So let's see how high we can go here. So we can see here. There we go. So actually, it's not getting as hot as I thought it would. If we compare it, let's actually do it with Venus again. Venus and Earth. So where are we? Oh, it's so weird. They've changed it. Oh god, I'm still not used to the new settings with the way they've done all this. So yeah, they go Venus and Earth. Earth's completely broken as normal from being in these new simulations. I'm just going to get those two to run. We'll have a quick comparison with those in our grand finale of this series. So yeah, Mercury, I was expecting more, I have to say. So yeah, very interesting stuff there. Let's see how Venus should be getting pretty hot as it normally does here. So let's just get the we'll get the surface grid on up and there. But yeah, that will probably go just to ridiculous numbers again. So let's really get this going. As we can see, when we did Venus, loads and loads of weeks ago now, Venus's temperature, due to its atmosphere as well, it absolutely went berserk. And the same with Earth, really. I believe Earth gave us very high results, as we can see here. Yeah, Earth gave us ridiculous results, but my theory, I'm guessing with Mercury, is since it doesn't have an atmosphere, although it is still getting warmed up a lot more than normal, my theory is it just doesn't have enough atmosphere to keep that heat in. I think that would be the only explanation I could think of. Yeah, the explanation. The only thing I can think of is it just doesn't have that atmosphere to really hold the heat in. Because obviously with even Earth being a lot further out, Earth's still getting way, way, way hotter. Like Earth's going up into like the 500s now. Earth's getting way hotter, and it must be due to that having that 1 ATM atmosphere. So 1 atmosphere of Earth, so surface pressure here. Oh, it's lowered for some reason. Earth's normally at 1. But yeah, Earth with normal value of 1. Obviously Venus has its massive value of 84, 85. But Mercury, on the other hand, absolutely ridiculously low. I mean, look, 0.00, like it's just absolutely gone. 10,000 kilograms mass. It's very, very light atmosphere, and I'm guessing that is the reason for Mercury being tidally locked, but it just doesn't have the atmosphere to really get that heat going. So I'm pretty sure if we move Venus or Earth to this area in the system, they would go even crazier than before. But I don't think Mercury just doesn't have that atmosphere to hold it. I don't think, and that, I guess, is the end of the series. And Mercury there, yeah, it just won't go any higher than about 356. It peaks at that by the looks of it. So yeah, there we go. And also it's a smaller object, so there's less area for the heat to spread as well, but I'm not sure it does really anything that. So yeah, there we go. Let's put trails on just so we can see everything. So yeah, if we go to Venus again, I'm pretty sure that's in the almost at 1,000 now. Yeah, we can see there the temperature's still spread around the dark side due to its massive atmosphere. That heat does get protected very well on Venus. I'm pretty sure with Earth, how we doing on Earth? So yeah, Earth, it looks like it's is it frozen at the moment? Let's just check that just to have a peek. But we can see, yeah, Earth's going into that 500s area. And it's looking like this right now. So yeah, it's frozen on one side. Oh yeah, because Earth has the water, doesn't it? So it freezes on one side, and the other side it starts to boil away. But yeah, there we go. So that's Earth and Venus. So yeah, those guys, they give you way better results. And it was the same with Mars, really. I believe if we just throw Mars into the mix, just to compare them all for our last episode today, even with Mars, I don't know what's going on there. But even, yeah, if we look at Mars, is it? No, what? I clicked on Mars, didn't I? Yeah. Is Mars broken? I think Mars is broken, so we may have to spawn a new one of those in. If we just put it to 0 degrees, maybe that'll help. No? Oh yeah, Mars has just gone very, very crazy. I don't know what's going on with Mars. It seems a bit bugged to me. But yeah, heading back to Mercury. So yeah, Mercury's grand total at the end, it seems to go up to around 357, 360, I think it went to there. Venus, obviously, that we got that to like 5,000 degrees or something ridiculous, if I remember right. Definitely multiple thousands. Earth as well, going up into that high 500 area. I believe we did get Earth to 1,000 when we originally did it. And yeah, Mars as well. We did get Mars to have molten rock on its surface, because obviously Mars, although further away from the sun, it does have more of an atmosphere than Mercury by far. So yeah, if we look here, obviously it's 1 Mars, but if we put that in kilograms, that's quite a high value, since Mercury only has a 10,000 kilograms in mass there. So yeah, obviously nothing compared to the Earth ATM, but still a massive value compared to what poor old Mercury has there. But we'll just spawn a new Mars in. I know it's not in the right place, but it's just to give us a rough example of what it could go up to. So there we go. So just put that Mars in. So yeah, now if we look at that, we also need to tidally lock it, just so we can really start to see things there. But yeah, I'm quite surprised by that. I really did think we'd see a higher value for Mercury. Like I thought we'd see its surface begin to melt. I reckon it, or my guess was it probably would have gone to around 700-800, maybe 1,000 if we are lucky. But the fact that it's not even broken the 500 mark, I am very surprised by that. I am really, really surprised. You guys let me know your thoughts down below in the comments there. But wow, I am very surprised that we didn't see a higher value for Mercury there. Maybe it's just me. I mean, we'll spawn in a regular Mercury as well. Maybe it's the modded Mercury that's a little broken, but it didn't make any difference with some of the other planets. So yeah, there we go. So I didn't tidally lock it, did it? And the only difference with this one anyway, it's got a different surface color. It's not like it's been completely changed in the code or anything. So there we go. Just spawn this one in, just to get a rough example. So if we go to surface, obviously go to temperature. So there we go. Similar results already, really. It's not really going any higher than that. We've got obviously a similar grid with a giant, like these two looking squares. Yeah, so yeah, not really. It's not the modded one that's making any difference. It literally is just how Mercury works. Anyways, let's go back to that Mars now. Is Mars? Okay, so it looks like we've got some better results than Mars. And yeah, here we go. This is a good example. Mars was going up into the 700s right there. And I believe its surface was melting at this point. Did we have some molten rock on the surface? I'm pretty sure we did. Yeah, so if you remember from the Mars episode, we did have molten rock on Mars there. I'm pretty sure Earth and Venus probably will have got a lot higher. Now, how's Earth and Venus doing? So Earth is at 500. Oh, so Earth's still only at 500. But we can see it's all evaporating up, and eventually it did melt. But it does take a little longer with Earth, I think. And then Venus, on the other hand, was just going absolutely crazy. They're almost at 2,000 degrees now with Venus. So yeah, there we go. So we can see the surface was completely molten on that. But yeah, back to Mercury. very, very surprised, I have to say, with that. I really did think it would go a lot higher than what it is. I mean, that's only 340, 350 it went up to. That's very petty. I really thought we'd see more results. But yeah, that does it for today's video, guys. So let me know your thoughts on this down below in the comments. But let me know what did you think Mercury would go to, or are you not surprised at all? Were you expecting Mercury to go into the thousands like I was, or not? Did you think it would only go to what the value it has right here? We'll see, but it's got to be with its atmosphere. That is my guess. Could be wrong there, and I'm not saying it's a fact, but that's my guess. I reckon it's just it doesn't have the atmosphere to hold all that heat in. I think too much is still getting out, although it's been Tidally Lock still. So yeah, pretty interesting to try all these experiments out and just see what the planets were like being Tidally Locked. We got, obviously, with all the planets we did, we got some interesting results. Obviously from the inner planets, they were definitely the best ones we did. But yeah, really interesting results from all of these guys, and I hope you guys enjoyed this series, because yeah, this is the last episode. I mean, we could try it with some other solar system planets, but yeah, I think our solar system in general here, I think we're done. Unless I mean, like objects like Ceres and stuff, I don't think we'd really need to do them. Like, I don't think there's much point. So yeah, that for now does it for this series. So yeah, like I said, I really hope you all enjoyed. Let's see if we can go for 40 likes on today's video for the finale of Tidally Locking Planets to the Sun. And yeah, that is everything. So make sure to subscribe if you're new. Helps on the journey to what's it, 13? Yeah, 13,000 now. Yeah, I'm losing track of the numbers here. Helps on the journey to 13,000 13,000 subscribers, guys. And yeah, make sure you all have a great day, and I'll see you in the next video. Goodbye.